Hey guys, what's up? I wanted to run through the way that I solved the 5x5 just to, so you can watch and see if you do it the same way. I don't know, might be a few things I encounter that, I can show you how I fix certain things that happen. Alright, well that should be plenty good enough, I would think. Alright, so first thing I do is make a vertical line on the white side. So just wherever I have to go to get that, so that vertical line, then I make vertical lines on the remaining sides, and then I just insert them into the right side. So there's a white line, there's the right side, so I'll do that. Then I've got one more line to make. To put that in, let's do that. Okay. Instead of doing yellow next, I do one of the sides that are on the side of the white. One of these, either the green or the blue. So do the green. So there's the green vertical line in the middle. There's another green line. So you gotta preserve the white side the whole time. That's the trick to it, is making sure that you preserve the centers that you've already solved. I guess you already know, but anyhow. And then when I get to this situation, just by putting this in, it messes up the white side. So instead, flip it around, put that green in another green's place, and then flip it around and bring that green back, and that fixes the white side with it. So I'm going to do another one. Let's do purple. Here's the same situation as before. I can't just put it there because it messes everything else, the other centers up. So flip it around, put the purple in the purple's place, and then flip it around and bring the purple back. And that preserves the ones that are already done. So, okay. Do the red next. So we've got a red line. Put it in, flip it around, put it back. I always have to look and make sure that I've still got the centers preserved, because sometimes I'll mess them up and not realize it until it's too late. When I get down to these last two centers, it gets kind of tricky. And basically I just swap out the colors, like these two yellows. I could swap them with these two blues. So bring the yellows in, bring it around, put that back. Now I got more blue on this side and more yellow on this side. Same with these two here. I need to swap these two blues with these two yellows. So bring these into the blue side, bring that around and put the yellows back. So now they're mostly the same. I don't know if you know how to do this algorithm that lets you switch any two dots. Like in this situation, these two yellows, these two yellows can be switched with these two blues right here. And there's an algorithm that'll let you switch one dot with another like that without messing anything else up. And it works like this. You bring that dot down that you want to switch, move the face to the left, bring that same dot down again, move the face back to the right, move that original side back up, move the face back to the left, and move that slice back up. And now you're left with one dot. Now it's just that dot and the other dot that need to be switched. So you did the same thing. Take that dot down, face to the left, take the same dot back down again, face to the right, bring the original slice back up, face to the left, and the second slice back up. So you can switch those dots. Anyhow, there's all the centers. And then I just do edge pairing like the 4x4. Except I line up all three at the same time. It used to be where I would line up two of them like that, go ahead and put them in another thing and swap it out with messed up edges. But then I got to the point that I would rather just go ahead and line up all three. There we go. So line up all three of them at once, swap that out with something else, and just reverse the centers back to the way they were. So there's one. Okay, now here's the situation I got with the last two edges. Is got that, and then that, the centerpiece is swapped between the two edges. And I can use the switching algorithm on that, or I could use a parity error algorithm where I use these two slices. No, that wouldn't work, never mind. I have to use the switching. I'll have to use the switching algorithm. And that did not work. Oh, I know what I gotta do. I gotta pair up two of them. Okay, I'm just gonna pair two edges and then do the flipping algorithm. So now there's going to be these two that need to be paired with this one. And the way to do that is to bring this green and purple into these two right here and do the flipping algorithm again. And that gives me parity on two edges. And I'm pretty sure if I do this algorithm one more time, it's going to fix that. And it did. So now all the edges are paired. Okay. And then do it like a 3x3. There's still another parity error that can happen from this point. I'm thinking there is any, maybe not. Oh, this is the E sheen, by the way. I thought my 4x4 was the E sheen, but I was wrong. This one here is actually the E sheen. It's my 5x5 that's E sheen. Yeah. Is that all it? Okay. didn't run through the parity errors, there's a couple that can happen. One parity error is when this entire edge piece is flipped, which prevents yellow cross, just like on the 4x4. The other parity error is when you're doing edge pairing and you get either the middle piece is flipped right here and these are correct, or these two pieces over here on the sides are flipped and the center is correct. You see what I'm saying? Like this piece, and this piece is normal, but these two are flipped. And then in the other case, that middle piece is flipped without these two next to it. And the corners would be the same way. It is either the three corners are flipped, or these two right here are flipped, or all three at once are flipped. And it's the same parity algorithms from the 4x4 that fixes all those errors. They're all the same algorithms. It's just the difference of when you go to do the algorithm, that one that uses left and right slices at the same time on the 4x4. On the 5x5, you got a choice of whether you want to flip the whole piece or just the middle, so that you would use either the outside edges for left and right, or you can use both edges for left and right, just like on the 4x4. When you do both edges, it's going to flip that middle piece individually. And when you do just the outside edges for left and right, it's going to flip these other two. So in some cases, you got to do one to get some pieces flipped, and then do the other to correct it all the way. But it's still the same algorithm. You just end up having to do it twice in some cases. The same is true for 7x7, except you might end up having to do it 4 times instead of 2, because there's so many different pieces that can be flipped, but they're always in pairs. So, and the same for the 9x9. That parity error, it fixes all the big cube parities. Both of those parity errors, actually. The 6x6, the 4x4 has that one parity error where the edge piece is flipped and it won't let you get the yellow cross on top. The 6x6 works the same way for that. If you can't get the white or yellow cross on the 6x6, it's that 4x4 parity error that flips that whole edge, the entire edge for you, so that you can get the yellow cross. But other than that, well, there you go.